Here we have AP pre-calculus problem. Okay, let's go the information. The function f is given by f of x equals to 2 log base phi of x, which is without the following describes f. Okay, we have four options. That is, in the first options, we have f is an increasing function. In the next two options, we have f is a decreasing function. Okay, to find whether f is increasing or decreasing, what we need to do is we have to plug in some random values for x and check whether f is increasing or decreasing. Usually when we have logarithm, the logarithm is defined only for the positive values of the argument. So here in the given logarithm, the argument is x and the base is phi. So the argument over here has to be a positive value. Always x has to be greater than 0. Okay, since x has to be greater than 0, we can plug in some random values for x so that x is greater than 0. Okay, now I start with x is equal to 1, then 2, then 3, then 4. Okay, so I increase the value of x at a constant rate, that is every time by just 1 unit, that is from 1 to 2, it increases by 1 unit, from 2 to 3, again it increases by 1 unit, from 3 to 4, again it increases by 1 unit. So when x increases at a constant rate, what's happening in the value of f of x? That we have to find. Okay, so when x equals to 1, now what is the value of this f of x? So for that we have to plug in x equals to 1 into the stuff which is equivalent to f of x. When I plug in x equals to 1, I'm getting 2 times log 1 to the base phi. So the value of this log 1 to the base phi is 0. Because for any logarithm, if the argument is 1, the base, it doesn't matter what the base we have. So if the argument of a logarithm is 1, so the value of such logarithm is 0. 0 when 0 is multiplied by 2, it becomes completely 0. So when x equals to 1, the value of f of x is 0. Okay, now let's find the value of f of x when x is equal to 2. So to get the value of f of x when x equals to 2, I just have to plug in x equals to 2 over here. So when I do so, I'm getting 2 log 2 to the base phi. Okay, how do I have to calculate the value of this one? We cannot use a calculator, regular calculator to get the value of this 2 log 2 to the base phi, because the regular calculator will give values for logarithm. So where the base of the logarithm is either 10 or e. So if a logarithm has a base e, it's called natural logarithm. So if a logarithm has base 10, it's common logarithm. So the regular calculator will give values for the logarithm when the base is 10, that is common logarithm, or when the base is e, that is natural logarithm. So if I want to get value for this 2 log to the base phi, my first work is to change the base phi to either base 10 or base e. Usually we will change the base to common logarithm, that is base 10. Okay, let's see how it is. Let me take this 2 times log 2 to the base phi. Okay, so whenever I want to change the base of a logarithm, what I need to do is I have to write 2 logarithms in division, that is log divided by log. Okay, now whatever base I want, I can take for both the logarithms over here, but I have to take the same base for both the logarithms in numerator and denominator. But here my aim is to get the base 10, so I can take base 10 for the logarithm in numerator and logarithm in denominator. Now for the logarithm in numerator, I have to take these 2 as argument, and for the logarithm in denominator, I have to take this base phi as argument. Okay, now what I need to do is I have to get the value of I can get the value of this logarithm, that is log 2 to the base 10, because it's base 10. So if I get the value of this log 2 to the base 10 using our calculator, I'm getting 0.3010, and it's a long decimal, it keeps going. And so when I multiply this value, I'll be getting 0.6 something. So it has to be divided by the value of log 5 to the base 10. So it is also a long decimal, it's 0.6989. So when I simplify all this one, I'm getting 0.8614. I just rounded to 4 decimal places. So I got the value of 2 times log 2 to the base phi. It's 0.8614. Okay, now to get the value of f of x when x is equal to 3, the same process what I've done over here. That is 2 times log 3 to the base phi, which is 2 times log 3 to the base 10 divided by log 5 to the base 10. Okay, now I can get the value of this log 3 to the base 10 from calculator, and it has to be multiplied by 2. So whatever result you are getting, the long decimal has to be divided by log 5 to the base 10. When I do so, I'm getting 1.3652. So when x is equal to 3, then f of x is 1.3652. And the same process we can do for when x is equal to 4. To get the value of f of x, that is I have to plug in x equals to 4, and I have to change the base to 10. So when I do so all the work, I'm getting f of x equals to 1.7227. So in each case, I rounded to 4 decimal places. Okay, now, so as I said already, x increases at a constant rate, that is every time by 1 unit. Now let's see how f of x changes. Okay, when x the value of x is increased from 1 to 2, look at it, f of x is increases from 0 to 0.8614, that is by 0.8614 units. When x increases from 2 to 3, f of x increases from 0.8614 to 1.3652, that is by 0.5038. When x increases from 3 to 4, f of x increases from 1.365 to 1.7227, that is by 0.3575. Okay, so now let's look at the change. When x increases at a constant rate, that is by 1 unit every time, so f of x also increases, that is from 0.80 to 0.8614, from 0.8614 to 1.3652, from 1.3652 to 1.7227. That is clearly f of x increases. But how it increases? Look at here. The first increase, that is from x is increase when x is increases from 1 to 2, f of x increases by 0.8614. This is the first increase. Just look at the second increase. It's 0.5038. The second increase is less than the first increase. Look at the third increase, which is 0.3575, which is less than the second increase. So every time the rate of increase is getting decreased. Look at it, decreases from 0.8614 to 0.5038. Again, the rate of increase is decreases by 0.5038 to 0.3575. So every time when x increases at a constant rate, that is by 1 unit, so f of x increases at a decreasing rate. So the correct answer choice for this question is option B, that is f is increasing function that increases at a decreasing rate.